Thank you. Thank you. Thank you very much. I know there are a lot of sessions running right now. I'm so glad you came to our session. My name is Arun Gupta. I work for Amazon Web Services. And with me today, I have Amit. We'll be talking about mastering Kubernetes on AWS. This session kind of builds very nicely upon, on top of what Abby just talked about. She talked in general about sort of how the container landscape looks like on AWS. Here, we'll be diving deep into Kubernetes aspect of it. It's not so much about the service, it's more about how this is running in production, what are sort of the key aspects that you need to be aware of. Oh, my windows are popping all over the place. So there are essentially three aspects. We have next 45 minutes, and we're looking at covering three aspects. And the way we're going to do the storytelling is, I'll talk about what are the options around Kubernetes cluster setup. Then Amit will talk about what are they doing it in production. Oh. Sorry. We solved it. All right, not bad. Well, the way we're going to tell the story is we'll start with Kubernetes cluster setup. I'll talk about it. Then Amit will talk about how they're doing it in production. Then I'll talk about what are the CI/CD options, how people are building deployment pipelines. Then Amit will talk about what are they doing. And then I'll finally talk about visibility. You may call that as logging, metrics, monitoring, all different ways. I'll show you the different options, and then we'll pass it back to Amit. So let's jump right into it. What are my choices if I want to set up a Kubernetes cluster on AWS today? There are plenty, actually. And what do you mean by setting up a cluster? Essentially, what it means is, how do I install, operate, upgrade, manage, patch a cluster? And if you understand the Kubernetes architecture, it has a master, it has a worker, setting those instances up. What does it take to get it up and running? Well, if you're doing development, then essentially you're doing development on your local machine. And what that means is you can fire up Minikube. Minikube is a single node Kubernetes cluster that you can fire up in your local machine. And that way, all of your environment is sitting on your laptop, disconnected, if you're flying in a plane, like I do all the time. So you can easily work on your machine very easily with that. If you're looking at the community-supported options, there are about 18 of those, at least at my last count. Kops, by far, is the most popular option that developers are using for creating Kubernetes clusters. How many of you are using Kops for creating Kubernetes clusters? Yeah, about 15% of you. So, that's pretty much the most common option I've seen for deploying Kubernetes cluster on AWS. The complete list, as I said, is on kubernetes-aws.io. Now, at last reInvent, we of course announced EKS, which is the managed Kubernetes service, which is in limited preview today. So the idea being that if you want to say, hey, I'm not in a business of managing a Kubernetes cluster, I want to focus on building my apps, then you go to Amazon console and you say, set up a Kubernetes cluster for me. We give you a control plane. You bring your worker nodes, very much like ECS, and then you build your applications with that. Of course, there are other options like CoreOS Tectonic and Red Hat OpenShift, which is basically one and the same company now. And then there are, of course, a variety of options using CloudFormation or Terraform, which gives you a lot more customizability, a lot more power. But as they say, with great power comes great responsibility. So it's not for the weak of the heart. And then we have a lot of partners as well. So Docker, Heptio, Mesosphere, all of these guys, they offer some sort of a Kubernetes offering as well. Now, let's take a look at Kops. Now, what does Kops give me? Well, Kops is a community-supported option. I know I work for AWS. I'm not really talking about EKS here because Abby already did the talking. But if I look at Kops, essentially, it's a community-supported offering. What does that mean? That means there is office hours for Kops. There is a Slack channel for Kops. So if you set up a cluster, if you are stuck in a production issue, that is sort of your way to go. You can generate CloudFormation or Terraform scripts with it. So let's say you set up your cluster once, then you can get the scripts out of it. The GitHub URL is over here. This is the command by which you can create a Kubernetes cluster using Kops. And all I'm saying is, I want to set up a cluster, or I want to create a cluster in this case, in 3 availability zones, and that is being specified by the availability zones. The state of the cluster by itself is stored in an S3 bucket. So I'm giving the location of that bucket. This is where my S3 bucket is going to be. And then I'm giving the number of masters. So you always want to have an odd number of masters, 1, 3, or 5. And then the master size, what is the EC2 instance type? Similarly, the node count and the node instance type. So once you specify that, then it just creates a cluster for you. And the bottom, if you see the last 2 options, first one is the networking option, which is basically one of the CNI or CNI provider. So Calico is one of the providers. And as part of EKS, we also announced the AWS CNI provider. So you can start using those. And by saying -- yes, simple thing is saying, OK, we'll create the cluster and create the resources as well. So COPS is the most prominent community-supported option that we have seen. Now, of course, you are still responsible for managing and upgrading and operating the cluster, making sure the backups are done. Now, if you're setting up a COPS cluster, by Kubernetes docs, it gives the recommendations that depending upon the number of pods in your cluster, you should set up the instance type. Should I set up etcd on the master or away from the master instance? How many number of masters? How many number of etcd? How often should I back up? What if my etcd goes down? What if my master goes down? Am I setting up auto-scaling group? I'm a node developer. Should I know about all these things? I don't need to. That's exactly the undifferentiated heavy lifting that EKS does for you. So it gives you a fully managed control plane. You just bring your worker nodes, you attach it to the control plane, and your cluster is ready to roll. Some of the core tenets, which is basically fundamental for the service itself, are it will allow you to run any enterprise workloads in a very classical way. Reliability, scalability, availability, all the elities, so to say, that you think of coming from Amazon are very much going to be part of this service as well. As Abby said, there is absolutely no forking of Kubernetes here. Everything is going to be done in the upstream way. Everything that you are aware of in the good sense from Kubernetes in the upstream, the skills that you are aware of, we want to bring them on as part of EKS. You're not required to use any AWS services, but we will provide a very seamless integration to all of those AWS services, such as CloudWatch, CloudTrail, ELB. You pick a service, ALB, NLB, whatever services that are around AWS ecosystem, we will provide full integration with those services. Those are not required, though. And last but not the least is what I'm most excited about is how the EKS team will contribute all bug fixes and patches and everything, not something inside the firewall, but outside in the upstream community. So that is sort of the most exciting part of it. So again, the APIs are very simple. We just say create cluster, cluster name, you give it the desired master version. It's in limited preview, so it's only available for customers at this point in time. And then you give it an IAM role, because that's the IAM role which will have the credentials of creating those EC2 instances. So how does it work? Well, today, if you look at it on Kubernetes, you have your EKS architecture, which is a master and an etcd, and you have your worker nodes down in at the bottom layer. Those are all spread across multiple availability zones. And it is very important that you think about that availability zone in order to build highly secure, available, resilient applications. And that's what basically this gives you. Now, from EKS perspective, we abstract the control plane for you. We give you a control plane which includes an API server, controller, scheduler, all the key components of the master by itself. And you still bring your worker nodes, and you attach the worker nodes to the control plane. And then you use the kubectl, which is the usual API on how you create, manage, deploy applications to talk to the master or the control plane. All right, let's take a look at it, how they do how Amit does it at Microfocus.
Hey. So I wanted to show you a product that we released recently, about half a year ago. And it is a cloud product that allows you to do all of your testing in the cloud. So it's something that we based on Kubernetes in the AWS cloud on EC2 instances. So this is basically the front screen that you'll get when you enter something about your test. So you get tracking for imported tests, some statistics, a graph showing you the trends, and so on. So the high-level solution is of Storm Runner Functional. We have web and mobile lab on the cloud. So if you need something, if you have a Mac and you don't have a PC, you can get that. Different browser versions, a lot of different devices, everything you need you can find there. A lot of tools integration, so the basic tools, Mercury, HP software / Micro Focus now. Tools are UFT and LeanFT, and then you have Selenium and open source tools. And also above that, you have a layer of reporting. You get your own reporting. You also get good reporting in the cloud. And you get analytics and integration and insights coming also from the production and your testing platform. So why use Kubernetes? So Kubernetes, basically you start from VMs, then you go to containers, and containers are very good, and they're dense, they're isolated, and you get a lot of good stuff. But you go to microservices, and then you have a lot of these containers, and you want to bind them together, allow them to recognize each other, get visibility, get logs, get monitoring, and everything that Kubernetes supports. So you get Kubernetes, and then you build upon that. Okay, so our clusters are actually organized in a kind of interesting way. We have dev cluster, staging cluster, and the production cluster, and that's no surprise. We have 2 production clusters. But the dev cluster uses namespaces in order to separate different environments. So you have a shared infrastructure layer. So one set of databases, Postgres, Redis, RabbitMQ, and so on. And then you share them with different namespaces where all the microservices are inside that namespace. So we go and deploy to an auto-deploy environment where you get all of the automated testing done. And then when you get to a level of maturity, you go to integration environment where the developers test their code. And after that, QA tests it and gets it in a stable environment, and it passes through the stages to staging, where you test the actual deployment, and production where everybody sees it. So you separate the infrastructure layer by having different schemas and different prefixes in Redis and RabbitMQ. Okay, so that really allows you for a lot of flexibility. So if you want to spin up a new environment, you don't need to create a whole cluster and take all the resources and build upon that. You can just spin up a namespace, and in that namespace, you get all of what you need. So if you want to do penetration testing, if you want to do some next version kind of production environment to test the next version, or maybe a patch version, then you can just spin up another environment inside this cluster. Okay, so we use kops. That's no surprise. It's a very good product. We did also look at kubespray. We started up with the kubeops script, which you just get from out of the box when you start with Kubernetes, but it's really not very maintained, and it's kind of a big 5,000 line script kind of thing, and it really binds you to a single base image. So you get all of the CNI networks and plugin support. You get different base images, supported AWS and GCP, and it's very good and well maintained. So we picked that. General architecture for SRF. So basically you have API gateway that routes everything to the different services. You have a management layer of a lot of different microservices. So you have about 20, 30 different microservices there. And then we have an execution layer where we isolate the execution subsystem, execution machines. Each execution machine has a Docker in a daemon set that controls that machine and spawns other Dockers. And this is used to run scripts that are uploaded from customers to the cloud. So it's very dangerous, and we isolate that with Dockers that can only access certain services, very pinpointed access, and they're always being created and destroyed. So we do this with Kubernetes because we get a lot of visibility, and it's very easy to deploy in a daemon set and upgrade with the daemon set. We usually upgrade it with a rolling update process. For the infrastructure, you can see we have the infrastructure layer. As we talked about in the previous slide, we have browser machines for the different instances that you want to use for testing for browsers, and we have S3 for hosting all of the files that come out. There's also a mobile lab on that corner that is attached to it. Physical cluster layout is very similar to what Arun showed. And so you have master nodes spread across different availability zones. And each of the layers is separated from the other for security reasons. But it has its own set of machines and its own scaling group. And Kubernetes just spreads out the instances of each pod, of each service to different availability zones. So we get high availability and resiliency. Okay, so our base setup uses base images that are homegrown. We use Ubuntu 16, but we harden it. So you get a very secure Ubuntu and not what you get from out of the box. We use the standard Kubernetes networking with Amazon routing. So there's a limit there of 50 machines, but you can always scale up the machines so you get more memory and more CPU resources. We are researching Calico, but mainly for the firewall between pods. The deployments in the developer machines are kind of different from Minikube. So we don't use Minikube because deploying with Docker Compose in the development machine allows you to really debug. So you can, obviously you can always open a port, but you debug on the machine, you can change the code, and you mount that code into the development Docker. So developer can really change his code and not need to rebuild the Docker, just restart that Docker, and the mount will just take care of mounting that code. Okay, so execution pools and I already explained. And about service configuration, we also have a hot deployment configuration service, which means that config map is very good for static configuration, but if you want to reload the configuration instantly and not close your Docker, that's a special case that we needed to have something different for. Okay.
All right, let's talk about what are my options if I want to create deployment pipeline for Kubernetes applications. So in terms of the deployment choices, of course, everybody loves Jenkins and hates Jenkins as well. As easy it is to get started with Jenkins, as easy it is to get lost in Jenkins. Which plugin, that plugin, I don't know. My head starts spinning very soon, rather. AWS has this set of suites, set of products, the code pipeline, code commit, code build, which work seamlessly for creating your pipeline. And again, in a very classical Amazon way, this is a fully managed service. And I'll show you how we expect this pipeline to work, particularly now how you can get it running for a Kubernetes application. And of course, there are a bunch of AWS partners that you can take a look at it. So GitLab, Shippable, CircleCI, CodeShip, lots of partners that provide similar offering. And some of them are actually managed as well. For me, the critical decision is when I'm choosing something, a product or a service or an offering is it my core competency? Is it something that I should be investing time in managing it? As opposed to like, yeah, this is something, somewhere sitting on the internet, and I can just access it and somebody else is managing it for me, where I can continue to focus on my core competency. And that's where code pipeline comes in very handy. Anyway, let's take a look at it. How we're seeing developers building their deployment pipelines using Jenkins. What you're seeing is basically a Jenkins file. In this Jenkins file, you can exactly define what your stages would look like. So for example, I have a stage called as checkout, where I say, OK, you know what? Check out this particular repo or clone this repo onto one of the slaves, assuming you have set up your Jenkins and all those things very good. Then you say, all right, I'm going to use a Docker file, because this is just a Java project or a Node project or a Python project. Use a Docker file to build my Docker image. Once you build the Docker image, you can push it to your repository of choice. whether it's Docker Hub, whether it's ECR, whatever your public repo is. Once again, you have to make sure that your credentials are configured accordingly so that the slave has the right privileges to be able to push to that registry. And last but not the least, you use the standard Kubernetes primitives to say, all right, I'm ready to actually do the deployment. So if you're updating a deployment, then typically there are ways by which you can do a rolling update of a deployment, again, very Kubernetes specific, or you can do a A/B using 2 deployments, scale one up, scale one down. So there are lots of those standard Kubernetes ways. Jenkins pretty much acts as just an orchestrator of how the solution is built. And if you can see, these are how sort of all the stages are shown. So I mean, you can see from checkout to build to post to update application. And then finally, I'm saying, all right, everything is green, so looks good. And then, of course, this Jenkins file is a Groovy file, essentially, which you write, and you can say how it needs to look like. Let's take a look at it, how I build something similar using code pipeline. So I'm a developer. I check in my code. So what I'm going to do is I'm going to go to the AWS console, say, create me a code pipeline. I get a code pipeline. Now, the code pipeline can be configured to pick up your code check-ins from code commit. You can have your code sitting in code commit, which is, again, a hosted Git repo. Or you can say, code commit, go talk to GitHub, because that's where my code is sitting. So you can do that as an option as well. Now, once you clone the repo, then you can say, use my code build service to do the building. You want to do that. Or I could say, you know what, I know how to build it, and I'll build it locally accordingly. Now, as soon as your code is built, you push it to an ECR, essentially, because imagine all of this is running on Amazon Cloud. So that makes it a lot easier if you push it to ECR, because this is all very easy to kind of pull it from ECR to a EC2 host, essentially. But the point being, as soon as your code build completes, building the application, it pushes the Docker image to ECR. It also triggers a Lambda. That, by the way, I'm done pushing that image to ECR. So it triggers a Lambda function. The Lambda function is written in Python, and it uses the Kubernetes Python API, which then talks to my Kubernetes cluster. It also has my Kubernetes credentials, because I should be able to talk to the Kubernetes cluster. So the Kubernetes credentials are stored in an encrypted manner, as Werner was saying. Dance like everybody's watching, encrypt like everybody. Well, dance like nobody's watching, but encrypt like everybody's watching. So those Kubernetes credentials are again stored in an encrypted manner with this Lambda function. So now Lambda function has my credentials. It can talk to the Kubernetes cluster. And then, of course, the Kubernetes cluster essentially pulls the image from the GitHub repo, or from the Docker Hub repo, or the ECR, wherever you push the application, and it gets it up and running. Now, this is available as a reference architecture. So you can literally follow the exact steps on how you want to get going with creating a simple pipeline for Kubernetes application. Right, Amit?
Hey. So our DevOps cycle, we have a lot of developers working on this project. Some of them are working on slightly other projects that integrate into this cloud. So we have 13 dev teams working in Java, Node.js, and Go, and they're always committing. So every commit triggers some kind of build and deploy cycle, and we have about 40 different GitHub repos, and everything is always running around and doing this stuff. So you can see it. Okay, so dedicated DevOps team works on building all of these pipelines and creating the different builds, and so upgrading, implementing pipelines and terraforms for the infrastructure, tweaking all of the Kubernetes manifest files, and so on. Okay, the DevOps cycle looks something like this. So you mainly start with commit from a developer, then it goes at Git. Jenkins gets a trigger, clones the repo, builds and tests unit tests, and then that goes, it basically goes into a Docker registry and two Docker registries. So one is local for the dev people to pull. The other one is the ECR registry, and actually a third one goes into an image file, gets pushed into a different repository where it's clear scanned, and we get some security and defect visibility, about security alerts there. Once it's inside ECR, Jenkins triggers rolling update request into the Kubernetes nodes, and the auto deployment environment gets that deployment, and everything here maybe takes about 10 or 15 minutes, and you get everything in the environments online, and you can test your code. So obviously you tested it first in your developer setup, but when you get to the cloud, you get it more mature. So our DevOps Stories started a couple of years ago, and we started with not knowing a lot about Kubernetes and Dockers and the right way of writing. Everything was kind of alpha or beta. So we started just taking Jenkins like it was and using Jenkins UI to configure jobs. So we ended up with a lot of jobs being infra-parameterized jobs that are being called by other pipeline-specific jobs that are being called by master orchestrator jobs, and everything was kind of a mess. And when the developer got mail that his commit, or maybe someone else's commit, but he's in the list that broke the pipeline, then he'll need to go and deal with all this mess of logs and click on all of these links until he found whatever was happening there. And he usually got lost along the way, so we really need to change that. So yeah, hard to trace, a tie between dev and DevOps, slow pipelines, and no versioning for the build system. So we shifted to build as code. It was kind of a long project. It took us about 2 to 3 months to implement, but we changed everything to be multi-stage Dockers. So you get your build environment into Docker with base image. You have Jenkins files for the tasks. You have a gulp to build the actual code. So it's usually Node.js TypeScript. We also have some Go. Kubernetes manifest file, obviously, for all of the YAML files you need to deploy. And for the environment, we also build environment as code. So we have Helm scripts, we have Terraform scripts to implement all of the installation of the different database and configuration. And we also have a packer to build the different OSs and different machines. We have both in AWS and stuff we want for Mac with templates in VMware. So everything is code. So everything is versioned. Everything is, okay, so it unties dev and DevOps. You don't need to have dev coming to DevOps saying, I need another pipeline, just please build this for me. You have full traceability, so once you go into Jenkins, it's just one job that you look at log and you can find your problem there, just search for error. Builds are carried on when you branch, then everything is committed to the Git repo, so the branch also includes all of the build instructions. And if you want to build that, you just go into Jenkins and say build this branch, and everything is already there. And obviously, you get a lot of visibility and reversibility because it's Git, so you can always check stuff.
Yeah. Well, one of the things we realize is, creating that self-service environment is very important, where you say, you know what, I don't have to go talk to somebody. And generally, I don't like talking to people. If there is something self-service on the web, particularly when I'm working, then it's a lot easier. And more importantly, it's a lot more scalable. I think that's the key. That's what you should really focus on. And that's what is really giving it to you. The other part that I want to focus is, I know a lot of you guys are taking pictures. Make sure you share them. Make sure you share them with your team. And the third part that I want to say before I get into this part is, what we are sharing here are some of the practices that have worked for us and our customers, like Amit. So we would love to hear your stories as well. Let's talk about visibility. Now, if you look at visibility in your cluster, what are the different things that need to be visible in your cluster? Well, there is a cluster, first of all, which is sort of the high-level abstract or the construct. Then within a cluster, you have multiple nodes, which are sort of the physical host where you need to get visibility on. Then on that node is where your container is running. So you need visibility on that. So that kind of gives you a full, nice visibility. But then you want a little bit different slice and dice where you can say, oh, I don't want a visibility on a container by itself, but show me sort of my heat map of my application. So those are some of the aspects that you're looking for on how, what sort of visibility do I want in my cluster. Now, when I say visibility, those are my artifacts on which I want visibility, but what do I want? Well, I want logs. Now, if something breaks, the first thing you want to check is, check the logs. Did you check the logs? Did you enable the logging? Go from info to debug log. So that's the first thing that anybody would ask. Then you're looking at metrics. How is my CPU utilization, memory utilization? Because that allows me to tune my cluster. Do I need to scale my cluster up, down, or set up my CloudWatch metrics, whatever that needs to be done? I'm looking at events, and events is like node going down, pod starting up. So those are my events that I want to start tracking. I could be looking at alerts that, oh, CPU threshold crossed. So based upon those alerts, again, I should be able to take actions. Sometimes it could be proactive, sometimes it could be reactive. And last but not the least, we're looking at tracing, because tracing is a critical part. Now, when you're building your application as a set of microservices, I'm just using the term microservices loosely, but a set of services, and you are running that application on Kubernetes, those are different applications running across multiple hosts. If I make a request from the outbound client into the application, and that travels across those 4 or 5 services, how do I trace what is going across my request? So that is an important aspect. So my point is, the 4 different places where you want visibility and what you want visibility on is sitting on the top. So you want each one for each one of those in an ideal case. But let's see. So if you look at logs, the easiest way to get logs, particularly if you're running a Kubernetes cluster, is kubectl logs. That's the most standard way. But that really gives you the log for a pod or a service, so you can get those logs. But that's about it. A lot of our customers we have seen using Fstack as well. So basically a combination of Elasticsearch, Fluentd, and Kibana. And you use Elasticsearch for indexing. Your logs are being sent to Fluentd for storing, and then you're building your own Kibana dashboard. So Fk is one of the ways, but let's see how the Fstack really works. So what I'm showing here is a 2-master, 4-worker node cluster, and those are spread across 2 availability zones, okay? Now, the way I would set up Fstack is essentially I will run a Fluentd as a daemon set that's running on each of the nodes over there. Anytime any action happens, so like say pod is doing something, it will write to the Docker daemon. Then from there, Fluentd will pick up that Docker log, and it will dump it into the CloudWatch logs. So CloudWatch logs kind of gives you a central place where all this would exist. Then from CloudWatch logs, there is a plugin that you can connect to saying, OK, just guide it to Elasticsearch, because that gives me easy way to search all the logs. And then on top of that, you can set up your own Kibana dashboard. So that's sort of, again, very easy way. I could really create this Fstack in a matter of few minutes, literally, not even hours. In a matter of few minutes, just spin up your Fluentd daemon set, connect it to CloudWatch, pick up Elasticsearch. There are pre-built Kibana dashboards available. Bring them in, and you're ready to roll. So that's one of the ways we're seeing it. In terms of metrics, we are seeing lots of different places where you're doing metrics. For node, you can certainly use node exporter. That gives you more details about the node itself, the physical host. For pod/container, there is, of course, kube state metrics, which is baked into Kubernetes, or you can use cAdvisor, which again gives you, which is a open source project, short name for container advisor, which gives you specific about the pod itself. And for application, you can use Prometheus style /metrics. So you can use, if you're using a Java application, so you can bake the Prometheus client in there, start exposing your metrics. Or maybe you could use your JMX metrics from the Java application and expose them at /metrics, which is using Prometheus style. Because then Prometheus will be able to scrape that URL and put them into a consolidated place. So those are sort of your metrics that you need at first level. Then you need some cluster-wide aggregators. So you could use Prometheus as an aggregator, picking from different sources, or you can use Heapster, because that will grab data as well. Now, these tools are continually evolving. So earlier, cAdvisor was only giving me about container. Now it gives me something about node as well. So depending upon what tools work in your organization to take a look at that. You need a data model where you need to store this database. Prometheus has a database, but you can also use InfluxDB or Graphite as a backend database where you want to store all this information. Now, all these metrics are good, but what do I do with it? I mean, I need somebody to tell me that, hey, something has gone wrong. So you need some sort of alerting capability on top of that. So then again, Alert Manager or Capacitor, those are open source offerings that you can use. Last but not the least, when I come back Monday morning, I want to see a fancy dashboard, colorful charts somehow. That, yeah, everything looked good. Nobody paged me. Nothing is on fire. Everything looks green. So I can keep doing my regular Monday emails as opposed to sit in the fire drill for next 5 hours. So those are some of the tools that we have seen our customers using in different aspects for metrics. Now, if you have a distributed application running in Kubernetes, how do you, we were talking about the tracing aspect of it. So how do you do that? So you want to really do that not only during development where everything seems to work a lot nicer and easier, but when shit breaks in production, that's when you want to be able to track it. That's when you want to be able to debug it, what's going on, what's going wrong. So that's the key part here. So you want to be able to identify the root cause and troubleshoot it, and then figure out, oh, now I need to do a new deployment essentially over there. And as I was saying earlier, you really want an end-to-end view of what's really happening, all the way from client to the backend database. I want a single tool. I call, every time you are switching a tool, you are more likely to lose it. I call that as a leaky bucket. So I prefer to use a single tool which gives me end-to-end, as opposed to saying, oh, for my Java application, I can use JMX. For my database, I'm going to use something else. From SQS, I'm going to use something else. Doesn't work for me. I want that consolidated end-to-end view over there. So once again, at AWS, we have XRay, which is a managed service. And what that gives you is you can instrument, XRay daemon. So XRay is a managed service as well, but XRay daemon is fully open sourced. And so what you can do is you can download XRay daemon. You can set it up as a daemon set. So now your XRay is running as a daemon set on your Kubernetes cluster. And now you have instrumented your application using XRay SDK. So whether it's Node or Python or Java, you pick your language, there is a XRay SDK. You instrument your application, and then as you make a request to your application, as your request is traveling through these different microservices as part of the same application, you can start defining segments and subsegments and sub-subsegments. And so for example, here I'm showing you a simple application that consists of 3 microservices. At any point of time, I can click on one of the segments and say, show me more details. And it'll start showing me traces. Then I can start identifying the bottlenecks that, oh, this one took about 110 milliseconds, and this took about only 10 milliseconds. So let me take a look at it, why this is taking 110 milliseconds. And you can start getting more details about it.
OK, so visibility in Microfocus. So for SRF, we use the Fstack, like you said. It really comes with Kubernetes. It's the way to go. And inside Kibana, so the Fstack is just a Docker daemon pushing the files into FluentD, and FluentD is indexing that into Elasticsearch. We also like to use a plugin called Logtrail to see the logs. So this is Logtrail in action. It's just open source. So we also collect browser machine logs and scripts and script execution logs. So the way we do it is we have a service that collects that and pushes them into a directory where FluentD can take them. OK, monitoring, very standard as well. We use Prometheus. We took Prometheus to collect all the metrics from different APIs and different infrastructure. So we also have exporters for Postgres, Elastic, and different others. And we also take applicative metrics. So we have custom metrics showing us the pools and the different usage of execution slots and so on. So the way it works, We use a Prometheus instance that is not part of the Kubernetes cluster because we wanted to have our monitoring system external to the cluster. So if there's some kind of problem, monitoring won't be down. And then we have some alerts. So you could see an alert dashboard here that shows us different alerts on the metrics we collect. And we collect metrics for liveliness, so whether a service is down or not, whether the whole system is down or not. We have CPU metrics that we get from Kubernetes, CPU, memory, I/O, and for each pod, API, latency, number of calls per second, and so on. Then we have the custom metrics. And we also have infra monitoring for everything, including Prometheus itself. So we found several problems like this, so seeing that there was a problem with IOPS or so on. Or maybe number of connections in the database, and you can see number of connections, cache hits, and so on in Postgres, for example, here. Most of the dashboards are easily downloadable from the Grafana site. So this is a baked dashboard that we just downloaded, and you get visibility to your whole cluster, and you can filter out different pods and services and see what they're doing right now. Memory usage, CPU usage, and so on. API dashboard is something that we did. We instrumented our code to display the different APIs and the time it takes to process them. And when you do load testing and you really want to see into the system and see which service and which API is doing the most problematic things, that you can see it here. And that's it.
Yeah, this is the workshop. Oh, thank you. Thank you. Now, if you want to get started with Kubernetes, this is a workshop that we built over last year. This is a workshop that was delivered at reInvent, at KubeCon, and we'll be giving this back again at KubeCon Copenhagen. So this workshop, if you have never played with Kubernetes, you can easily spend a week just doing this workshop. It's meant for newbies who want to get started with Kubernetes, so it kind of explains the basic concepts of Kubernetes. It takes you, how do you set up a Kubernetes cluster? How do you do monitoring? How do you do logging? Entire concepts. It does all of that. Debugging, local development. It has a lot of details about how do you want to get started with it. So I would highly recommend take a look at this workshop. Not only that, I particularly work in the open source team. So I'm looking for, I want this to be an extremely collaborative way. So if you look at it, there are about 1,000 stars to the workshop. There are about 300 people in this room. So if each one of you give a star to the repo, I don't see why it cannot shoot up to 1,200 right now. More importantly, I'm looking forward to your contributions. File the issues that, Arun, I would like to see this in this workshop, and that is not there. Or better, up the ante. Say, I'm going to send a pull request, or this is not working. Every commit that you make, every pull request that you make, whether it's a simple typo, it's a comma, it's a punctuation, or it's a new chapter, makes the workshop that much more better. So we are looking for it. And as Werner said, go build. Me and Amit are going to be outside for taking your questions. And I'm going to be in the AWS booth if you want to talk more about anything around Kubernetes or containers at AWS. Thank you.